Welcome to Executives at the Edge, a podcast brought to you by MEF. I'm your host, Pascal Menezes. Join me as we explore thought-provoking perspectives from the leaders and change makers who are propelling enterprise digital transformation forward. I am so really excited to have Tiffany Brown, CEO of Sage Management, join us at Executives at the Edge. And Tiffany, welcome. So delighted to have you. And in today's episode, we're really going to cover really how does the whole ordering process of how two providers order from each other, which today is very manual, and then how can that be automated using blockchain? And I got to tell you, this is really, really amazing what blockchain can do for the outcomes, and the benefits is just incredible. So Tiffany, tell us a little bit about your background, a little bit, and then the company's background. If we could start there, that'd be really great.
Sure. I've been in the telecom industry for 25 years, and with Sage Management was founded in 2004. And we've been the entire time trying to fix broken billing and ordering systems and correct all of those issues after the fact. And so we're excited about partnering with MEF and correcting things before they get broken. So we've spent the first 25 years of our career fixing things after, and we're going to spend the next 25 years of our career proactively fixing it so it doesn't ever break to start with.
And what's so exciting is that we're moving into a whole new technology paradigm, right? And specifically on today, we're going to talk a lot about blockchain and specifically how that technology can really impact and deliver tremendous value into your business and into this whole idea of how do you manage these expenses and so on. So Tiffany, these days it seems that everybody is talking about blockchains. We know this is the key technology that's going to drive the metaverse and Web 3.0, but how important is blockchain for the telecom space? Can you elaborate on that?
Sure. Blockchain is essential. I'm convinced that it's the only way to fix the issues that are out there, long-standing issues in the telecom industry. The systems in the telecom space were built in the 90s around highly regulated legacy TDM networks. And now with deregulation, modernized network services, all of that is now being forced into that old TDM billing and ordering model through patchwork, manual processes, swivel chair processes, workarounds. The carriers and all the third parties involved have been trying to fix this for decades, and all of the workarounds are still rife with error. And so what we've found is even the best carriers make errors on 20% of their orders. So that means 1 in every 5 orders goes out with errors that cause the billing systems to be triggered and triggering non-optimal contract vehicles, triggering invalid rates, terms, conditions. And so then on the other end of that, you have the telecom invoices, and statistically, we found 70% of telecom invoices contain errors, and those error rates are astounding. The carriers have tried for 25 years that I've been involved to create patches to fix it, and it just doesn't work. The reason blockchain is necessary, and I think it's the only path forward, is it completely eliminates these archaic systems. It's the only path that truly eliminates the systems that are broken. It allows for mutual endorsement, a single source of truth, including mutual agreement on price, rates, terms, conditions at the time of order. And I've never seen any other solution achieve that outside of a blockchain environment.
Now, if we could just, for our listeners, just maybe explain the manual processes that go on right now before we get to the blockchain and how to implement that and automate that. So I remember you talking about, this is about ordering and ordering optimization and getting the cost recovery. So can you help our listeners understand just the use case of that?
Sure. So Carriers have teams of people that their entire jobs are just to place the order. They have ordering teams, provisioning teams, and they're working off of job aids because all of these new technologies, even something like Ethernet that's been around for forever, doesn't really fit into the legacy TDM billing and ordering systems. And so even for something as simple as ordering an Ethernet circuit, you have a provisioner going in using a job aid to figure out what field they're supposed to put in all of the different pages and pages of fields on the ASR, which is an access service request order. And if one of those fields is filled out incorrectly, it will trigger the wrong thing in the billing systems. So all of the billing systems are built around every single one of those fields on the order. Every single value produces a different thing on the billing end. And so the engineers use the orders to figure out how to provision the circuit, how to get the circuit up and running. And what physically gets provisioned is worked out with the engineers. They go back and forth through the ordering process and figure out, what are you really trying to order? They're able to work around those ordering problems. So typically what physically gets engineered is accurate, but the billing system doesn't know what was physically engineered. They only know what was filled out on hundreds of fields in an order. And so the billing system uses whatever's there. It has no artificial intelligence to figure out what was really supposed to be there. It just goes directly off of what was there. And then it defaults, if it doesn't understand something that's in one of those fields, it defaults to the highest rates possible, deregulated service guide rates. And so where you have maybe 60 different contract vehicles that billing system is pulling from, it's going to pull from the highest one as a default if it doesn't understand the order. And so some of it is there are fields on the order that just aren't filled out properly. And so it comes up with an invalid result on the billing side that triggers a deregulated service guide type rate, which is astronomically high. Or it's that it did put in a correct contract value, but it chose the wrong contract vehicle. So it might have chosen the third best contract vehicle with that value, but it really could have been more optimal.
So what this now, your company goes in and says, and looks at the order and says, and all what was implemented, and comes back and corrects the billing and correct it. And sometimes there's a recovery that is 20% errors that makes the party there that got billed that says, hey, no, this is not right. And you actually, that's what your company does, right? It says, no, based on the order that actually got provisioned, you're overpaying, right? And so it should be this amount. So you correct the billing side. Do I have it right?
That's what we do. That's what we've done for the last 25 years, is correct it after it gets billed wrong.
Right.
We go through and then we have to correct the order, correct the billing, get all of that done. But what happens is by the time all of that happens, you submit a dispute, it gets put into a settlement. You go to settle things out. Our clients get pennies on the dollar for what they paid out of pocket that was wrong. And so they get a fraction of what they would have gotten. And so in the last 25 years, we've saved our clients $4 billion.
Wow.
And that's a fraction of the savings that they would have had in a blockchain environment where we, at the point of order, correct it. So it never goes on the ledger wrong to start with. It never gets billed incorrectly. You never spend the dollar incorrectly. So you're not getting pennies on a dollar then. You're getting the full value of your dollar because it never hits that ledger wrong. It gets optimized, corrected, change orders get put through before the circuit's installed, before the service is up and running. And so now once it hits the ledger, it can be mutually endorsed and you have the optimal pricing rates, terms and conditions for that service that both sides can endorse and say, yes, this is accurate.
That is awesome. So how would this work? So we have the MEF order API. Would that play into and there's a blockchain, there's a smart contract. Can you just walk our listeners through and you codify the smart contracts to understand these nuances of all of these different fields? And then, so can you help us? And then you have analytics that then applies to that and figures it out. Can you help our listeners out now how the smart contract with the ordering APIs MEF's doing would and walk through that use case, how we codify that into an automation model.
Yes, absolutely. So standardized APIs are critical to this process. It's why we're so involved with MEF. It's why we're so excited about what's happening at MEF, because for this to really get fixed, you have to fix these pieces, right? And the only way to do that is in a standardized global way. And so having APIs where, there's the telecom industry at large, all of the expertise from, combined expertise from all the MEF members coming together and saying, these are the APIs, this is what we need. So now everybody can get on MEF APIs, which is what we're, really pointing all of our carrier clients towards, is adopting those standardized APIs so that everybody's talking the same thing when we're talking about ordering and what flows into the blockchain DLT. And then from there, what we do is we work in phases. So we would take someone who doesn't know anything about blockchain, doesn't know anything about anything, and we would say, okay, first let's join MEF, right? Let's get together, get the standards done. And as we're working through those standards, let's just, as phase one, let's rate your entire embedded base. So every order you've ever placed on every circuit, it could be millions of orders, depending on how large that embedded base is. But let's codify and build out the logic for a smart contract based on every contract vehicle that you have ordered from for all of these different services that you're utilizing. And we do that in a self-funded way. So there's no budget needed, there's no upfront costs. We do it based on, we bill a percentage of the savings that you get from issuing, correcting orders and getting those savings going forward. So that would be our first recommendation, is let's get a smart contract codified based on your entire embedded base and how you're ordering and what you're doing right now currently.
Okay, so now let's say that's the first phase. You do all of that. What happens next?
So then there are different carriers feel differently. There are challenges that different carriers have. I'll give you an example. Implementing full blockchain, some carriers are concerned about security. And so many of the largest carriers right now are utilizing private blockchain ledgers, which take a considerable budget. It's very expensive. It takes in-house blockchain expertise, which most carriers don't have. And so right now we're working live in private blockchain scenarios, private blockchain ledgers, because of the security concerns. But we know now with zero knowledge proofs that zero knowledge proofs eliminate those security concerns related to public blockchain ledgers. So we're really excited about that. And we're looking forward to working with MEF to stand up a ZK EVM scaling solution for MEF members, so that once you have the smart contract built, once you have the APIs and all of that is standard, now the ZK EVM environment is scalable, it's secure, and we believe that that answers those questions for especially the smaller carriers related to security. It takes care of the complexity of the technology itself, and it gives a solid path towards blockchain for all carriers and enterprises. And even our largest carrier clients, we're talking about zero knowledge proofs now to say, this is the future, this is where it's heading, let's go this direction. And so I would say once phase one is complete and we start rating orders in real time, we're real time rating orders. It's still under the old billing and ordering system, but we're real time rating it. Now we can start to move to ordering APIs, a ZK EVM environment where there's an actual public ledger, right? That's secure, where each carrier maintains the data within their own secure databases, but there's a ZK, a zero knowledge proof that's publicly published. And so we're excited about that. We really do believe that's the path towards blockchain for all carriers and enterprises going forward.
So for our listeners, because it seems zero knowledge proof, ZK EVMs, it's kind of all very technical, but let's back it up a little bit. So currently private blockchains are used, and the data of those orders are stored on the private blockchain. That's kind of what they do. And
That's
No one
correct.
wants to store your data on a private blockchain or on a blockchain generally. But private blockchains mean, now, is it a blockchain on a telecom blockchain with multiple carriers, or is it every carrier, AT&T, Verizon uses one blockchain and then, two other carriers use a different blockchain, or is there a telecom private blockchain for everybody to use and they store their data there? Can you just start there for a second?
Yeah, so currently it is private blockchains with just the two carriers involved. So if it's, two large carriers, only those two large carriers would have access to that data. There would be no one else that would be able to see that data. It's very secure. And so each time you stand up a new carrier in that environment, you stand up a new private blockchain with just the two carriers involved.
Okay, great. So that's number one. And it's expensive, as you talked about, because private blockchains are expensive to putting your transactions on that blockchain. So now let's talk about zero knowledge proof. So what's happened is in 2022, there was the idea of the baseline protocol that came out. And there was also the idea of Ethereum, which is a public blockchain, came out with the idea of Ethereum Enterprise. And they said, hey, how can we use a public blockchain with the goal of keeping it very secure, right, for enterprises, that has a very low cost, okay, and can scale in performance, correct? And now this idea of zero knowledge proof came out to deliver on this idea. And now, can you help our listeners walk through exactly that? How does that work now with zero knowledge proofs, public blockchains? There's layer 1, layer 2. Because I think this is really important. I mean, our listeners, I know, would love to understand this because it's so confusing.
Yeah, I mean, I think just to kind of simplify it, with zero knowledge, you contain the data in your own secure warehouse. So you don't publish any of your pricing, of your, locations, all of that data that the carriers are very concerned about. You don't publish any of that in a public space that could be, hacked or whatever. And so you keep all of that data internally secure in your own warehouse. And then the other side, the other member or whoever else is involved in that, keeps their own data as well within their own warehouse. And so you've each got your own data in a secure place that you're comfortable with, that meets all of your security concerns, and you're housing that data. And then what gets published publicly is a tag to that data. So it allows both people to mutually endorse, yes, we both agreed to the pricing for that tag, the rates, terms, conditions for that tag. But the tag itself, if that gets hacked, it gives no one any information. It doesn't have pricing, location. It doesn't have any type of information that would require security around it.
Yeah, no, it's brilliant. So basically, and that goes on the public blockchain, that tag, if you want to call that tag. It's an index to the data, right? But the tag also has to be stamped with some kind of identity, some kind of credential to say that transaction really did happen. You can trust it. It's not something fake put on there, right? So I don't want to describe, but you know what I'm saying. So zero knowledge proof gives you all of this, and it has to work also with our integrated trust network, and that is also the idea of having a decentralized ID, right? Some kind of digital decentralized ID that can be assigned to each of these carriers so that they can stamp their records, and there's a root of trust on those IDs because they self-sign their own DID, which is like a certificate, and basically that's their identity. But there's a root of trust. In this case, MEF or some authority says that, like a centralized authority, or like a CA model in PKI. Basically, what happens is that this key has a valid digital ID that says, yes, that it can't be repudiated. It truly is that transaction, right? Do I have that right, or am I got that wrong?
Yeah, no, that's correct. And that's a vital part. And that's what, is being done in the private blockchains now. But in the public blockchain, it would be the same trusted certification that this is mutually endorsed. Both parties agree, they trust it. Nobody can go back later and say, no, that was the wrong rate, or we're going to back bill you something later, or we're going to have this settlement of disputes later. None of that exists because it's a trusted, mutually endorsed certification.
And so there's a lot of complexity involved here now because you're talking about so many moving parts. And what I think you're doing in a project in MEF is bringing all these moving parts together into the zero knowledge proof or the zero knowledge EVM. So it's Ethereum virtual machine, right? Where you can run the smart contract. Do I have that correct?
Yes, that's correct.
And that smart contract is run on some kind of virtual machine. It's got the zero knowledge proof that we talked about. And then from the outcome of that tag gets put in the public blockchain for every transaction, correct?
That's correct,
Yeah,
yes.
And so you're putting together all of this infrastructure in MEF in the showcase to show this, to be a generic model of a blockchain as a service using all these public blockchains and having all the scale, performance, price, and so on. So then you can build smart contracts, not just for settling on this ordering and to optimize the ordering process, but you could also do it for other use cases, like we're seeing for ENIs or for SLAs, or there's all kinds of telecom use cases that can use this generic infrastructure, this blockchain as a service, and you can build smart contracts in the zero knowledge EVMs for specific use cases. Do I have that correct?
Yes, that's correct. And I really believe that the first pilot use case we'll do with MEF will be for SLAs, actually, because we've got a really good smart contract built with MEF, and we have partners there that are using it. And so I really do believe that SLAs will be the first pilot case, which is great because when you sign service level agreements and say, we're agreeing to this, and the other party says, yes, we agree, and then it's never followed up on, the data is lost, nobody can agree. You have one technician on one side saying, no, that was your fault. Another technician on another side saying, no, it's your fault. You don't get an outage credit, or you don't get overall SLA2 credits or any of that because of XYZ. So in this case, it's really helpful to have one source of truth that both parties agree to and say, yes, this is what happened. This is accurate at the time that it happens, right? Not 2 years later when you're trying to figure out what happened and the technicians don't remember. At the moment it happens, the ticket goes in, they agree what the closure codes are, everything goes through, and now this is what is owed for an outage credit, or an outage credit is not owed, and it's because of this reason. And this is a major problem for carriers and enterprises because they spend a lot of time and resources figuring that out and trying to unwind it all way after the fact. And it takes a significant amount of time. And so to be able to just eliminate all of that at the time of the ticket, everybody agrees this is what happened, this is how it got closed, and credit is due or no credit is due, this is what is due. So I really do think that will be the very first use case for the ZK EVM model with MEF.
And that's using now a different API. That would be using the trouble ticketing API, not the ordering API.
That's correct.
Kind of cool. So I think this blockchain is a lot of complexity to get to the scale, performance, and price we talked about using public blockchain. You're at Sage Management doing the thought leadership and really driving this innovation for the telecom industry. And I'm very appreciative of what you're doing there. And you bring all those moving parts to make it simple. And what would you give the advice now to the telecom carriers, enterprise? Like, how do they get on this journey? Do they join your project? The CFOs are worried about, like, there's a lot of concerns about, exposure of data and will it really work correctly? Does it sell correctly? I'm used to my old processes. They're not perfectly, but, what I know is kind of what I know, and I fear the unknown. So how could you help these operators on that journey? Like what would be your advice as we wrap this up?
Yeah, sure. So we've talked a lot about security, and I think that if the carriers can understand the ZK EVM model, I think that we can kind of move past some of those security concerns that they have. Another concern is just, a lot of blockchain companies don't know telecom, and telecom companies don't know blockchain. And so being able to have, organizations like MEF, trusted third parties to make sure that the technology is implemented with 100% accuracy, right? The last thing anybody wants is for a bunch more bad data to be put out there and then to be put on an immutable blockchain ledger. That's not what anybody wants. And so you need to have those trusted third parties, the standardizations, all of that working together for you so that you can kind of be confident in that first step. And it's really having experts that understand the networking, the engineering, the design, the billing, ordering, provisioning, regulatory rulings, the wide-ranging contract vehicles available. And a traditional blockchain company just doesn't understand the complexities of all of that in the telecom space. So it's important to have a third party that has really deep telecom expertise helping, to guide that process. And another thing is, one concern is integration with existing systems and processes, right? So taking it in phases, I think, is important. A full implementation of blockchain requires changes to existing systems and processes, and it can be time consuming, expensive, right? So we want to approach it in a phased way. So we say, phase one funds itself with savings as you go. Start to build out the logic of the smart contract, looking at all the contract vehicles that you've ordered from in the past. Start getting to where you can rate orders in real time, right? And then start getting to, a blockchain solution that makes sense for you, working through, MEF and trusted third parties to help through that process. And I mean, in the end, we're seeing many carriers successfully implementing blockchain and realizing significant benefits. And I can say, based on decades of experience in the telecom industry, I can say with confidence that the benefits outweigh the challenges. But we recognize that there are challenges and we want to help walk people through those challenges. But in the end, you're able to move from, as an example, 70% error rates on telecom invoices to, we have a live, private blockchain environment where we're seeing 99.98% accuracy prior to posting on the ledger, with some quality assurance checks on the 0.02% of fallout, and then 100% accuracy once it's posted on the ledger. So there's no comparison between the accuracy of the current billing and ordering model and blockchain.
And as you go to, this network as a service or on-demand services and cloud-like experiences, it has to be elastic. And so that elasticity has to be reflected in the whole building. And today they don't do that. It's more of a static model. You buy it at this price, at this speed and so on, and it can't change. So across the ecosystem, there is no elasticity, which is not a cloud model, right?
Right.
And that's exactly a hard problem. Blockchain will solve this exactly the way you described it. So the values are just as you described, very high accuracy, huge cost savings, basically funds for itself. So how does our listeners are listening to this and say, I want to get involved? What's your call to action?
So my call to action would be, if you're not a MEF member already, become a MEF member, join MEF, join standardizations, get involved, start to join. And don't just join and sit there, start to join the calls, be a part of the committees, right? Join a use case. We have use cases right now running for ordering, for SLAs, so join a use case and start that process of just working through phases to rate your inventory, develop a smart contracted for rated ordering, engage consultants that understand telecom and blockchain, and get started within MEF in one of the use cases so that you can see the benefits. And as you're getting the financial benefits, you can fund further phases in blockchain.
Yeah, so join MEF and join the showcase where we do these POCs, or the proof of concepts, and kind of mature them to a point where they can get in production grade quality and to be deployed. And so you can join it, learn about it, and then basically get into a plan of how to deploy it into production and work with your CFOs and your upper management and so on, and actually get a plan. And at the end of the day, the outcome and the benefits are massive in value to everybody. And so thank you, Tiffany. It's been really enlightening for our listeners, for you to have this huge expertise in blockchain and all of this ordering process. And I think what you're doing at MEF for Sage Management is just outstanding. And building this just generic, zero trust, zero knowledge EVM, we're using public blockchains and tying to identity and all this complexity, and making that simple to use for all these use cases will be a massive contribution to the industry. So we thank you so much for sponsoring and being part of the thought leadership in this area.
Absolutely. Thank you so much, Pascal. It's been a 25-year dream come true for me. I didn't know that we would ever get here to where we can fix all these problems before they happen. And so it's a dream come true for me. I really appreciate it.
Isn't that so true that you have this vision and a passion, and you just wait for the day to just everybody, the whole industry adopts your vision, passion, and it makes you feel like you made huge impact. And so I applaud
absolutely.
you. Applaud you.
Thank you so much, Pascal.